Good morning, everyone. Well, good morning, good afternoon, wherever you are. Today, we're taking a look at the Pi adapter for OPC UA. Today's session is essentially a extension to our administration classes. If you haven't taken our administration classes, the links are down below. I'm kind of assuming that you have. I'm not really going to go through the prerequisite knowledge for this. It's also sort of an extension to the last stream I did on the Pi connector for OPC UA. Another note is you can follow along yourself while I'm going through the configuration. I should remove this starting soon. There we go. You can go through the configuration yourself as I'm going through the configuration. You need to boot an environment and you need to have a subscription. If you're not sure what that is, there are links down below. All right. Another thing to say is please ask questions as we go through. Any on-topic questions, I'll try to answer as they come. Any off-topic questions, I'll probably leave until the end and then come back. So you're welcome to use the chat. Please ask questions as you go and I'll try and answer them. Now, let's take a look at our subject matter for today. The Pi adapter for OPC UA. Now, why would you want to use the Pi adapter for OPC UA? So generally, I'm going to start off with a little whiteboarding while we go. If you do want to boot an environment, you can still boot it, and by the time I finish whiteboarding, it'll probably be up, and you can follow along with me. But let's see. So here's our scenario, and here's the scenario we're going to go through in the live configuration part of this session. We're essentially going to install and configure the Pi adapter for OPC UA. On this side of things, we have a distributed control system. And over on the other side, we have a user. For example, this is an engineer. One of the pumps has malfunctioned and they want to see what's going on. So they'd like to see what this pump is doing, but the problem is that they're in headquarters and the pump is on site. So how does the data get from the pump to them so they can look into the problem? I'll build up a little bit of the architecture here that we're going to look at and where the adapter fits in. So here we have a OPC UA server. And the DCS is really exposing all of the sensor data for all the equipment down there using this OPC UA server. And over here, we have our user, and our user is going to connect to a data archive. So here we have a Pi data archive, and the user is using Excel or something like that. There we go. And they make a connection here. So the data archive stores tags or points, and these contain streams of data coming from sensors through our DCS and through whatever we've got in between. Okay, so we're talking about what's in between here. And previous sessions have gone over different architectures that you can have. So way back when I was doing the Pi System Administration live streams and our admin courses, which are linked down below, they go through interface configuration. So you can have interfaces in between here. Our last live stream went through connectors, and you can have connectors in between here. So I won't go too in-depth in connectors. You can check out the previous stream for that. Here, we're going through adapters. So here, we're going to configure an adapter. So this will be Pi adapter for OPC UA. So OPC UA adapter. And it is going to write to the Pi data archive through Pi Web API. This is our little chain here. All right. This looks sort of similar to the connector kind of data chain that we had last time, but we had a connector instead of the adapter and the connector relay instead of PyWeb API. We also had another part in our architecture last time, which was the PyDCM, the data collection manager. It's the way of managing the connector. Adapters don't have this. Adapters are configured by, well, usually by a command line tool. So there's a little command line tool called Edgecmd. And we, as an administrator, this is us. You know it's us. You know it's us because we've got a hat on. There we go. We're going to use Edgecmd, and Edgecmd is going to configure this adapter. So we're going to start off with an adapter that has no configuration. We're going to go and tell it to connect to the backend OPC UA server, what data to read from that server, and where to send the data from there on. Right. Couple more details before we get into configuration. Is operating systems. So today, with the system that I'm using, everything's actually installed on the same machine. That's just really for testing and demonstration purposes. The nice thing about adapters is that if they were all installed on different machines, the configuration would be exactly the same. There is no difference in configuration whether they're on the same machine or different. So you can imagine we're flipping between different machines here, but we're all everything's on the same machine for our system. The other thing to note is PyWeb API has to be Windows, and Data Archive also has to be Windows. So you're locked into Windows here, but the OPC UA adapter and server are platform agnostic. Well, a little more platform agnostic. So the OPC UA adapter is supported on Windows and Debian-based Linux. It's also supported running inside a container, if that's your thing. We're going to use Windows all the way down in this case, but the configuration on Linux, again, is no different if we're using Edgecmd. Really, the slash is around the other way around. That's really the only difference in configuration. Okay, so one concern the administrators may have when they're watching this is, so you're telling us we're just going to use a command line tool to configure the adapter. And, well, yes, that's exactly what we're going to do. So we're going to use this command line tool to configure the adapter, but that's really the exciting bit. That's why I'm actually really excited about this technology. I'm excited because, finally, I don't need to use a user interface to configure the adapter. In this case, we're going to do it manually, but while we're configuring it, we're going to make a script to configure it for us. And essentially, after we have this script, this doesn't need to be us anymore. This is my attempt at drawing a robot. There we go. A robot can run that script afterwards. So any kind of deployment tool, Azure DevOps, Azure IoT Hub, there are many other vendors with platforms that can do this. All you need is a platform that can deploy servers to run this adapter and run a script on them. And then it can just configure it for you. This means that if you've got hundreds or thousands of data sources to read from, this is actually manageable. If you're using interfaces or connectors, having hundreds or thousands of them, that's a full-time job for multiple people. In this case, it's pretty easy to automate. All right. There's a question about simulation tools for interfacing it to MES applications. I'm not sure that I have one. I'll I'll come back to that at the end of the class and see if I can answer it. All right. So this is why we want to use it, and this is the architecture we're going to follow as we configure it. All right. This is our environment here. Everything's installed on one machine in our case, and we're going to configure it. Now, I did lie when I said exactly what we were going to do in this class. I said we're going to install and configure the adapter. We're not going to install it. It's actually already installed on this machine, but installing it is literally running an MSI file on this machine for the adapter, and then another MSI file for Edgecmd. Installing it on Debian is very similar. You would install the adapter and Edgecmd using the binaries you can download. Okay, so that the installation is actually already done. We're going to start configuring it. Okay, let's check out Edgecmd and what we can do with it. So I'm going to open up a command prompt here. Maybe I'm going to zoom in a little. And run my first Edgecmd command. Once Edgecmd is installed, I can use it. So Edgecmd help. This is the simplest command I can run. And it shows me the help for Edgecmd. Now, I don't tend to use this command very often. I tend to use the documentation. The documentation for Edgecmd and also for the adapter itself is also linked down the bottom. A really useful part of the Edgecmd help is under reference Edgecmd commands, where it goes through a lot of example commands you can do and then what those accomplish. So while you're configuring one of these, I really recommend having this open. All right. So that's all well and good. I could just configure the whole adapter by typing in this command prompt here. And does everyone want to see me type commands for an hour? I know you want that, but we're going to build up a script. And it'll be a little easier to keep track of what I'm doing while I'm doing that. You can use really any tool here, but in this session, I'm going to use PowerShell. So if you're following along with me and you've got the image, inside this class files folder on the desktop, there's a bunch of empty PowerShell scripts. I'm going to open up this one. Really, it's just an empty file named PS1. And this is where I'm going to type the commands to configure the adapter. Okay, so I can type that same command in here. And essentially, I'm starting to write a script here. Let's maybe zoom in a little. A little easier for everyone to see. So Edgecmd help, and I can run it line by line with run selection. So you can use any tool to develop this script. You don't need to use PowerShell ISE. I'm just using PowerShell ISE because it's already on the machine, and we can run things line by line. Okay. So running Edgecmd help gave me all of the help. Now let's run a command that actually does something. So the next command I'll run is Edgecmd get version. This will connect to the default port for adapters on the local machine, and then ask it what its version is. So there it is. We have connected to an installation of PyAdapter for OPC UA, and that's its version. So essentially what we just did, we're no longer a robot. We ran Edgecmd on the machine, connected to the adapter, and asked the adapter what its version was. And we got the output. And this is really what we're going to do for most of the rest of the session. Right. Let's get some more interesting details about the adapter's configuration. Edgecmd get application. Okay, now we're talking. So if we run a command, it gives us back text in this format. This format's called JSON. You've probably seen it around, but it's really a pretty standard way of expressing structured data. So we get back the configuration. So Edgecmd get application gets the full configuration for our application. And what's kind of nice is we've just exported the full configuration for our application. And if we want to back it up, that's all we do. We run that. Okay, so let's take a look at little bits of this. So we've got these top level objects called System Ingress. These, we're going to talk about these in a little bit. These top level storage objects. When I zoomed in, it looks like it didn't work. Sorry about that. Looks like the stream doesn't like that. All right. These top level objects, we're going to talk about configuring them in a little bit. We're going to add another one for our adapter. But these contain different sections of configuration. So we're going to ignore most of the system ones. We're going to leave all of these at defaults, really. OMF egress is ultimately what we're going to configure to push data out from our adapter to our PyWeb API. All right. So let's take a look at actually configuring our adapter. You'll notice that our adapter has no details about what it can read from or even what it can write to, except for this empty OMF egress part. All right. Our next step is to configure a component. That system and OMF egress, those were components. Those were top-level objects to house configuration, to do something. So let's take a look at what that actually is. I'll just make some room here. Yeah, we know what that is. Doesn't matter if I'm blocking it. All right. Okay. So let's talk about adapter configuration. When we make configuration changes to our adapter, we have to do these configuration changes to a component. We already had one component here called OMF egress. That was in our configuration. Ultimately, we're going to tell that component to send data out to the PyWeb API when we get there. We're going to configure another component here to house the rest of our configuration. You can think of equivalency for interface. A component is a interface instance. A little bit. So this component, when we configure it, it'll be called simulator because it is reading from an OPC UA server or OPC UA simulator in our case. This really should be called, the component should align with whatever you're reading from. We're going to create this component. It's going to be a kind of blank storage space for the rest of our configuration. Ultimately, we're going to tell the adapter through telling this component what to connect to, what tags to read from, that kind of thing. All right. Let's create our component. The first thing I want to do before creating it is seeing what components we already have. So Edgecmd get components. will grab us what components we already have. So we see we already have this OMF egress and nothing else. And that has essentially, well, effectively, no configuration. Let's make a new component. Edgecmd, this is a new verb, add components. We need to give it an ID, simulator, and a type. Okay, so this ID, if you're doing this in real life, not in the simulation, is or should align with the source you're reading from. Okay, let's run this line. Operation is completed successfully. Great. We can run the previous line and then see what components we have. So now we have two. We have our OMF egress, and we have this new simulator of component type OPC UA. Okay. We're on the right track. Now, next step is to tell our component where to grab data from. So we're going to tell our component what to connect to, what OPC UA server to connect to, and then it is going to reach out and connect to this OPC UA server. So we need to add a data source. Okay, here we go. Edgecmd set data source. So this is a pretty long one. I'm going to split it out into multiple lines. In PowerShell, to split it out into multiple lines, maybe I'll zoom in a little bit more. There we go. Everyone watching on a phone can thank me. Okay. Edgecmd set data source. And this character, if you are unfamiliar with PowerShell and you are following along with me, this is a backtick. I actually have no idea how to do it on a QWERTY keyboard. Google it. But now we're going CID simulator. We're telling it to add a data source to the component with ID simulator. And the endpoint URL, so the OPC UA server's address that we want it to connect to, is going to be using the OPC TCP protocol. Uh, 127.0.0.1, which is localhost, so the OPC server running on the same machine as the adapter. In your case, if you were doing it in a real system, it'll probably be a different address. And on port 49320, which is the port that our OPC server is installed on. And we want to use a secure connection. If you don't have this flagged, a lot of OPC servers will just say, no, you're not going to connect to me with no authentication. You're joking. All right. So let's see. I'm going to select all this and then run it. Endpoint URL field is required. Looks like I made a typo. Thank you, Edgecmd. All right, completed successfully. Fantastic. So how do we see if our changes were successful? We can get the data source from the component with ID simulator. Okay, great. So below is our configuration, the data source. It used what we put in and then a couple of defaults. Okay, great. So that means that we've added our data source. The adapter will actually try to connect straight away. Do you think it was successful in connecting? Who's getting flashbacks to the OPC UA connector stream? I know I am. Let's check the logs. So, one thing we really should have had open this whole time is the log for our container. Not the log for our adapter. The logs for adapters are in their installation directory, and then the adapter that we've installed, which is OPC UA, and inside logs. Each component has its own log file. So we saw that system component, that's really a hidden component that has its own log file. There's some information in there about internal workings of the adapter. We also have OMF egress, that other component that we're going to eventually connect out to our PyWeb API. And we have simulator, the one we just made. So let's go into that. I'm opening this in a tool called Atom. It's a text editor that will automatically update if we see any more, if any more lines come into that log file. Okay, were we successful in connecting? Anyone want to take a guess in the chat? There we go. Text wrapper's on now. I'm not sure what the delay is in the YouTube stream. Well, the answer is no. We were not successful. Let's see. So it looks like we've got a few errors. Server certificate isn't trusted. Please verify the certificate. And then connection failed down the bottom. All right. And let's make it a little nicer for everyone with phones. Okay. So why is this the case? You should be getting, if you saw the OPC UA stream, you should be getting flashbacks to that. It's the same reason as we were having security problems in our OPC connector stream. So how does OPC UA security work? So here's two little objects. We have our OPC UA server on the left. We have the OPC UA adapter on the right. And they have these three little storage locations for certificates. Our OPC UA server, here's its certificate. By the way, I am simplifying this for our stream here. This is not exactly how it works, but effectively for what we're doing, it is how it works. So our OPC UA server has a certificate, and our OPC UA adapter has its own certificate. Okay. When a connection is attempted, our OPC adapter sent its certificate over to our OPC UA server, and the server went, okay, this certificate I was just sent, is it in my trusted directory? No. Okay. I'm going to reject it. And the OPC UA server sent us back. That was supposed to be a copy and paste. OneNote really doesn't like me today. Okay, OneNote. There we go. So our OPC UA server sent us over its certificate, and our OPC UA adapter went, is it in my trusted folder? No. So I'm going to reject it. So that was the actual error that we saw. OPC server's certificate is not trusted. Okay, how do we fix that? What we do is we go into the configuration. So this is us. We go and grab this certificate and then move it down there. Then we'll do the same thing to the OPC UA server. And then the next time it connects, it will trust the server. So let's go ahead and do that. I'm going to go back to Windows File Explorer and into OPC UA and into certificates. So we've got some folders here. We have own. That's where its own certificates lie. And we've got rejected certs. So we've got this cap server EX, which is our simulator. I'm going to cut this and then go up to certificates, into trusted, inserts, and then paste it here. So I've effectively moved it from the rejected to trusted. Hey, look, we got a log message. Okay. We got a warning saying the OPC server certificate is misconfigured. Don't worry about that. I just didn't bother fixing it. But that's just a warning. That is fine. Now, we have a different error. Connection failed. Bad certificate invalid. So that's an error actually coming from the OPC UA server saying it doesn't trust our certificate. Okay. So let's go and get the OPC UA server to trust us. Now, depending on the OPC UA server, performing this action will be different. Some OPC UA servers, you will go and move a certificate from one folder to another. This one's a little different. This is cap server. We're going to right-click on the rejected certificate and say trust. And this effectively moves it down to trusted. Okay. So how to do this in cap server, and this will be different. These steps will be completely different no matter what, depending on the vendor that you're using. I'm just down in my tray down here. I'm going to right click and go OPC UA configuration. And trusted clients, we see Pi adapter for OPC UA is untrusted. It was denied. So we're going to right click and trust it. So pretty simple with cap server at least. As I said, different vendors will have different procedures for this. You check documentation from the OPC vendor. And most likely, you, as the Pi system admin, may not be able to do this. You'll need to tell your OPC server administrator to do this for you. And they'll probably have to do it down the chain in the control network. Okay. Now we've done that. The next time we try and connect, hey, look at this. Successfully connected to the source endpoint. So we have a successful connection. All right. Now, let's take a look at where we're at. We configured our data source. So we told our OPC UA adapter to go to this OPC UA server and connect to it. And we configured the security. So we have done that step. the next step will be to tell it what data items to gather from our OPC UA server. So what streams, what tags or points should I grab from the OPC UA server and then push over to the data archive? Now, adapters are not like interfaces. You don't create the tags for adapters. Adapters will create their own tags. So the tags are actually configured on the adapter itself. We're going to do this using discoveries. So we're going to say, okay, simulator component, go and connect to your OPC UA server and gather up, or do a search for tags on the OPC UA server and gather up a big list of tags. And then export it to a file, basically, is what we're going to do. So let's go and do that. So the discovery, a discovery is this action. Go and grab a list of tags. So let's see how to configure that. We're back in our script now. Let's add a discovery. So we're adding a discovery to something with component ID simulator. The ID of the discovery is going to be called pumps. Looks like I forgot my backtick. And our query is going to be an OPC UA query. I'm not going to go over the syntax here. You can look it up in the documentation, but really what we're looking for on our OPC server is the root node ID for our search is going to be namespace 2. In namespace 2, and our node is going to be simulation examples pumps. Right. So that means we're searching for objects under namespace 2 in our OPC UA server. And in an OPC UA server, all of the streams of data that it's exposing are sorted into a hierarchy. We're walking down the hierarchy from down into so namespace 2, simulation examples, pumps. And we're grabbing everything underneath pumps. Now, doing this in the real world, you'll need to work with whatever team manages your OPC UA server and then see what a sensible query is for you to gather what you want to gather. All right. Let's run it and see what happens. Okay, that's run. Let's look at what happened with the log file. When we ran that command, it connected to the OPC UA server. It started a discovery with ID pumps. And then it completed its discovery. Great. Doesn't tell us what it did, but we can look at the results. So let's see. We're going to, I'll just cheat and use copy and paste. You don't want to see me type for an hour. We're going to get discoveries with CID simulator ID pumps, and we want the result of the discovery. Okay. Looks like it found a bunch of stuff. So this is the big list of tags that it found on the OPC server. And these are all sensors coming out of pumps, and a couple of system tags as well. Okay, great. So we've got our list of tags. We're not reading from them yet. There is one thing that we could have done here. When we added our discovery, we could have just added our auto select true. And that would have performed our discovery and then just started reading from all the tags. And then once we configure our egress, right out to our system. Now, if I was configuring hundreds or thousands of these, maybe that would be a good idea. But in this situation, I actually want to take a look at what the tags are before it starts reading from them and creating them on the PyData archive. So we're not going to use the auto select. We're going to take a look at them. But before we take a look at them all, we're going to take a look at data filters. So we've got this big list of tags. We're going to configure a data selection and give it this big list of tags and say, select all this data from the source and start writing it out. Now, there's a few options we have here. We can configure data filtering. Now, if you've attended the other administrator classes, data filtering is a little bit like exception in interfaces. So, for example, we have a tag here. So this might be a pressure. We might get a value of 100 kPa. Ultimately, we're going to get this data sent over to our server, and it'll send over that value of 100. What if a second later it reads 101? But the sensitivity of our instrumentation is only to the nearest 5 kPa. Do we want to store that 101? Do we want to bother sending it? We can filter it out. We can add in a deadband here if we want to. So the equivalent here, if you're familiar with interfaces, is we're going to set up exception. And we do this again on the adapter side if we're using adapters. So let's take a look at the data filters we already have. Edgecmd get data filters from the component with ID simulator. When you make a new component, it comes with a data filter for free. This one. Duplicate data. It has a deadband of 0 and an expiration period of 1 hour, which means if we assign one of the tags that's going to get to this data filter, it will only send, it won't send the same data more than once in a row. So it won't send the same value more than once in a row unless an hour passes. And then it'll send the value again. Performs very similarly to exception. If you're not familiar with the concept, search our YouTube channel for exception and compression. That video will talk about it in terms of interfaces. This adapter will work fairly similarly to how it works in the interface. Okay. Let's make another data filter. So we're going to Edgecmd add data filter. To simulator, this data filter is going to have an ID of 1 unit deadband. And I have made a typo here. the absolute deadband is going to be 1. And the expiration period is going to be 600. Okay, so this will be a 1 unit deadband. Like I said before, if that pressure is at 100, if we get a reading of 100.5, that reading will not be sent through. It'll just be thrown out until we get something that it has at least a 1 unit difference to the previous value. So adding this data filter effectively makes it available to us when we configure the next section, which is our data selection. There we go. It's completed successfully, and we can get data filters again. Let's see what data filters we have available to us when we're setting up that data selection. So now we have 2, the duplicate data, and 1 unit deadband. Excellent. And note that expiration period, that's in seconds. You can also write, I could have written 10:00 for 10 minutes if I wanted to. Right. Let's configure our data selection. I can just copy the one from up here. To configure our data selection, we're going to grab that full list from our discovery. So there's our discovery result. We're going to add on, we're going to output to a file. And the file we're going to output to, I'm just going to cheat rather than writing it out because I'm probably going to make a typo, is this file. So it just writes it out to a CSV rather than showing it to us on the screen. Okay. And we tell it to write a CSV. Otherwise, it'll just give us a JSON. Right. Let's run it. Okay. Let's open that up. So I put it in the class files directory, and there it is. Okay. So here's our full list of streams that we got in the discovery. So again, what we're looking at here is after we asked the OPC UA server, did that search on it and say, what have you got for us? This is what it told us. This is what we have for you. We're going to configure it, massage it a little bit inside Excel, then export it again and say, okay, OPC UA adapter, I'd like you to now start reading from this stuff. Right. So we're going to make some changes here. So a little more detail on what all of these columns are. Node ID, this is the name of the stream on the OPC UA server side. So we're going to keep this as is. This is the ID on the OPC UA server side. We're going to make some changes here. So first off, stream ID. This will be the name of the tags on our data archive. We're going to make a few changes to this. I'd like to take off some of the prefixes. So I'm going to select the column and remove the 2.simulation examples. And I forgot to remove the other dot. That will not work. Let's start again, shall we? We're removing 2.simulation examples dot. Okay, that's a little better. And I've just noticed that for those on phones, it may be a little small. There we go. Okay. I'm also going to sort it. Let's see here. We're going to sort by stream ID. Okay. So we've got this production data, bearing temp, flow rate, oil pressure, etc. And we also have these kind of internal system data at the top. I don't care about those. I don't really want to create them on my system. So I'm just going to remove them. All the rest of them, though, they're good. That's the production data in our system. I'm going to change selected to true. So when we export this, it will actually select them and start reading from them. And then the data filter ID, I'm going to add my 1 unit deadband. So I'm going to be careful here and just add it to my analog tags, not my digital tags. The status is actually a digital tag. There we go. I'm pretty happy with this. I'll exit and save it. Okay. And once I've got that saved, I can set the data selection of my adapter. This will give my adapter a big list of tags, then say, yep, I want you to start reading from all these tags. So then it'll start reading data from the whole list. And then once we configure an egress, send it out. Right. We are setting a data selection for the component with ID simulator from a file, the file we just saved. And the file has the format of CSV. All right. We've completed it successfully, and we can check our log to see what's happening. Okay, excellent. It attempted to add items to the subscription. It contains 30 items. That's what we expect. Great. And it started a history recovery, and then it succeeded. Well, it didn't succeed its history recovery because the server does not support history recovery. Okay, if your OPC server does, then history recovery will be performed. In this case, they are new tags. History recovery will most likely not work. But if the adapter gets turned off, when it turns on again, it will look back at when the last time it read data and automatically fill in the gaps. And that history recovery is configurable. So check the documentation if you're interested in it. Right. Let's configure our egress. So configure writing out to our data archive. Edgecmd add data endpoints. Now, this is going to have an ID of PyServer01 because that's the name of the machine we want to write to. You can really give this whatever ID you like. But it makes most sense if this matches the machine that you're going to write out to. Now, endpoint. Here we're telling it where to write to. Now, we're configuring this OMF egress to write out to our PyWeb API. Now, another nice thing about adapters is they don't just support writing out to the PyData archive, also other data stores. So this, if we wanted to, could write out to Azure Data, to Aviva Data Hub, or to Edge Data Store. So those are both repositories for streams data, similar to, or sort of similar to Data Archive. They structure data very differently. If you're interested in Aviva Data Hub or Edge Data Store, then we have done previous live streams that have covered them a little. Documentation will be in docs.osasoft.com, which I've linked down the bottom. Okay. So we're configuring that link out, our egress. In this case, we're sending through to a PyWeb API instance. PyWeb API accepts data using HTTPS and the address of our PyWeb API. Specifically, the OMF endpoint of PyWeb API. So if you are using this, when you install PyWeb API, you need to enable the OMF endpoint feature. So this bit that we're connecting to here is the OMF endpoint. As long as that feature is enabled and configured, we can write to it. When we write to it, we have to provide credentials to authenticate. Our username, and we have 2 backslashes because we're in PowerShell and backslash is an escape character. We need to put 2 of them. This is where if you were using Linux and a shell script, your slashes would be a little different, and you'd need to look at what escape characters for shell scripts are and go from there. All right, our usernames, adapter, and password. Okay. Note, once we save this, I'll give it a save. This has saved our password and username in plain text. That's very naughty. In this case, we're making a script and saving it. If we were using some kind of deployment tool, we would store this username and password as some kind of encrypted variable and then use that. But we're just writing a plain script here. When it is saved into the adapter, so once we run this command, the password is encrypted. Okay. So let's run this. It's completed successfully. And if I want to get my data endpoints, so let's see what it did with that password. Did not like that. Okay. So we see that the passwords, it doesn't tell us what the password is. The password's encrypted internally inside the adapter. And you can't extract it once it's been set. Okay, let's take a look at our log, see what happened. Nothing. That's because the log for egress is a different log. So we can go into that if we want to. Inside adapters, we can go into logs and look at our OMF egress log. Here we go. So at 9 a.m., which is right now, new OMF data endpoint added, and that's it. We see no errors, so I think nothing's gone wrong. Let's check the system log. Let's check all of the logs. All right. I do get an error. I actually didn't expect that. It makes it more fun. Okay. That is a 824. Oh, that's fine. That's just when we added the when we configured the component simulator, there was no data endpoint. That's fine. That's when we ran the command. And I made the typo of endpoint URL. I said endpoint URL or something like that. That's the error message that came through there. So we get no errors. So we expect now to have data in our data archive. So we can read that with really any tool we want. I have system management tools open. I may as well read that. We are administrators after all. And this really is fairly small for everyone with phones here, but, well, just for fun, I might open up Pipe Vision while I'm at it. We can do a tag search. And all of my tags from our source had the word pump in them. So let's check those. There we go. That did not detect that I pressed select all. Yep. Okay. And we'll be getting data now. So these tags did not exist before. The OPC UA adapter created them. So it told the web API to create the tags. All right. Note also, these have a prefix of simulator. The component name does prefix the tag name, which is quite nice. It tells you where it's come from. All right. So really, one benefit here is no tag maintenance. One benefit over interfaces, at least, is no tag maintenance. If you've worked with interfaces before, you end up spending most of your time maintaining tags. But in this case, well, you kind of need to maintain them a little bit on the OPC adapter side, but that can be programmatically done very easily or scripted. All right, let's see vision, just for fun. We can make a new display and we can look for our pump tags. Okay, and train a couple of these. Okay, so they started getting data just a few minutes ago. Four minutes was too short. we've started to get data from these tags a few minutes ago, and they'll just update in real time from there. If our adapter goes down, it will perform a history recovery, which may or may not be supported by the server. If the link between our adapter and our endpoint goes down, so if these links go down, the adapter will buffer data. So buffering is already configured. You don't need to configure it like interfaces after the fact. It's already there. Okay. So I'm pretty happy with this. And we've got our data. So now's the time to ask questions if you have them. I'm going to do a couple of other things just to show off really what you can do with adapters. The last thing I'm going to do is go Edgecmd, get application with file OPC UA adapter configuration configuration.json. Okay. If I run this will export my whole configuration to a JSON file. I'll just open it in Atom here. So this is my whole configuration, including all of my data items and everything. If I wanted to apply this to a different adapter, all I'd run, well, I would copy over this JSON file and then run Edgecmd set application with that file. I can run it now. It won't really do much, but so this will apply this whole configuration to the adapter. Edgecmd. Yeah, this happens when I go off script. Let's check the documentation. Application configuration. Edgecmd set application minus file path. Oh. Backtick. I just revealed my secret of how I know how to configure adapters. The magic documentation is actually the documentation for Edgecmd utility. And then underneath the reference, Edgecmd commands. If you want to do something, it's probably here. Okay. Looks like we have failed. Creator update is not supported. Maybe because I'm trying to write over configuration that's already there. Again, this happens when I go off script. I go off script a lot. So applying it to a new one should be fine. We can actually, let's go off script more and have some fun. Anyone have any questions? I'm finished what I was really wanting to go over in this session. Now I'm playing with it for fun. But really, what we could do is just go and simulator. No, it'll be too hard to make another component. Yeah, that's for another time. So to recap, what we've done here is we have configured an OPC UA adapter from scratch using just command line commands. And as I said right at the start, anyone who's administered the Pi system for a while, kind of their eyes would widen there and go, you're doing what? But when you're dealing with a lot of systems, you'll welcome this. This makes it much, much easier to configure and to apply it to multiple systems. Taking advantage of that export and set, even though it didn't work for us because our adapter was already running, but taking advantage of that and taking advantage of the fact that now this script here, although it does far more than just configure the adapter, I can save that, and now I have basically a script to configure the adapter from scratch. As I said before, really, I'll just reconfigure this to probably what I would do if I was trying to have a default script to configure a whole bunch of different adapters configured to read from different sources. I'd probably just go and add a component, set the data source. This data source will probably be a variable, and I'd use whatever platform I was using to deploy this to insert a variable there. And the CID will probably be a variable as well. I would add a discovery, and then probably just do auto, I've forgotten what it is now. Auto select true. And that's really it. All the way down to adding data endpoints. Okay, there's my script. So effectively, this script would configure an adapter from scratch. Things that I would need to parameterize in my script if I was going to deploy this in bulk. It's probably the CID, probably the endpoint URL, probably the query, and maybe the ID of the discovery, and then the data endpoint. If I parameterized all of that and said, yeah, do it 100 times with slightly different parameters each time. Nice and fun. And really, that's why I'm really excited about this. One thing that is missing here is some kind of failover. There was a post in feedback.osisoft.com recently that that is currently under development and that is coming. So failover for adapters is coming, and I'm really looking forward to that as well. Once it does come, you can look forward to another stream from me configuring it, because I'll be even more excited. And when that does come, really, we have a nice replacement for interfaces that is very easily applied to many, many systems and much more easily works with their IoT kind of platforms. All right. Another thing to note here, I didn't really go over firewalls, but there's really the firewalls that I have here. You have your process control network over here. You have a demilitarized zone here, and you have your corporate network here. nice and simple. What's also really nice is that the OPC UA adapter and the server they're not required to be on a domain at all. It doesn't matter. There's no extra configuration if they're not on a domain. Your Pi Web API and your data archive need to be on Windows and really should be in the same domain as each other. But that's pretty standard. So the other thing that excites me here is that it's much easier to get adapters and make them fit into standard architectures with standard kind of domain and Active Directory controls. All right. That's really all I wanted to do for today. We just leave that junk down there. If anyone has any questions, feel free to ask them, but otherwise I'll sign off. I'll wait another 30 seconds or so for any questions that come in. If you are following along using the image, you'll find in the manual, I followed the first sort of half of it in this stream, deviated a little bit, but you'll find that the manual goes on to use the Pi adapter for Modbus, TCP, and Pi adapter for MQTT as well. All right. And with that, there's no questions, so I'll sign off. Thank you very much for watching, and feel free to comment down below if you have further questions. Thanks again.